So we have a talk this morning on the world's most dangerous, well, I think the world's most dangerous file format, which I'm sure you all know and love, perfect for spear phishing. So I give you Julia Wolf and PDF. Oh my God. Oh.
All right, so I'm Julia, like you said. I work at FireEye and I do malware analysis and whatever else needs to be analyzed, basically research. This is my first time speaking at CCC, and I'm amazed this many people are awake at 11 in the morning. But so how many people here have ever, or how many people have not heard of PDF? Okay, good. So how many people here know that you can play a QuickTime movie or render 3D animation inside of a PDF document? Okay, that's pretty good. So I'm going to cover a few of the features, or a somewhat slightly, not quite exhaustive list of features that are in the PDF spec, and a couple other interesting things about it too. This is the basic outline following. So Acrobat was written mostly back in the 90s. It's about 15 million lines of code, and to put that in perspective, Firefox is about 2.7 million lines of code. I'm pretty sure the 15 million includes like Flash and QuickTime or something, I don't know. But it's got a lot of stuff built into it. PDF was sort of a reaction to PostScript. There's a couple of problems with PostScript. It's basically forth with a bunch of graphics operators. So in order to display page 100, you had to execute the code from pages 1 through 99 first. And it could take forever because it's actually a fully Turing-complete language. It may ray trace a sphere on a checkerboard or something while you're somewhere between pages 1 and 100. So what PDF is basically just a bunch of objects connected together in a kind of a tree. It looks kind of like this. You can write it, it's all basically 7-bit ASCII, although it's 8-bit clean. This is an object. It says it's a page, and it's this big. This is an action. It's a JavaScript action, like it says, and that's the JavaScript that gets run. So it's actually pretty easy to read. One of the things is the philosophy behind PDF changed a bit, has been shifting over the years also, and Acrobat has, Adobe has also sort of conceptually recast PDF as being a container format that is sort of an archive that you can put a bunch of other files into and to get the exact same files back out again sometimes later. So remember that. Adobe submitted the PDF 1.7 spec to the ISO to make it an official standard. It's ISO 32000-1:2008 is the current revision. And like right at the beginning, the reason I did this talk was sometime last year I actually sat down and read through the entire spec, and the entire time I was like, oh my God, what were they thinking? I told FX, it's like, oh, I want to give a talk at PH Neutral, and he's like, okay. And so I had to come up with something. So I talked about this. Right at the very beginning of the spec, it says that there's nothing in this document for validating the conformance of a PDF file or a reader to the spec. And that's extremely true, because there is, in fact, for many PDF files, there is, in fact, no way to know what the correct interpretation of the file is. So so quick list of features. This is actually all in the ISO spec. It enumerates this stuff. So you can do OpenGL, and you can have like JavaScript events attached to various actions on the 3D objects and so forth. There's a database connector, it's like ODBC, and there's a funny thing in the spec about that too. It says that there's no security for any of the databases that the user has access to. It's up to the database administrator to keep all their data secure, because PDF has access to all of the databases that the user reading the PDF has access to, apparently. So you can embed a Flash file, run it, play sound and video. There's a full-blown XML form based thing that does, it has like its own macro language called form calc, which is another Turing-complete language included in PDF. It generates barcodes. You can do RSA public key signing of the data and so forth. There's also this, bought this like the day before yesterday. One of the special barcodes types is an RFID type, and it's not nearly as exciting as it sounds. There's apparently certain printers that instead of printing a barcode or something, will print the information to an RFID tag. But there's an actual data type defined for it. So JavaScript, there's JavaScript now in PDF. It has a full XML RPC library. You can JavaScript running, when the PDF's running inside of a browser, it can send events back up to the JavaScript. The JavaScript in the PDF can send events back up to JavaScript running in the browser, and vice versa. You can do a little bit of writing to disk. Older versions, it's much more restricted now, but like in old versions of Acrobat, you could like read and write to any file on disk. There's globally persistent, hang on, the microphone's falling off. There's globally persistent data. What's his name? The guy who's doing EverCookie, I mentioned this to him also, because it's one of the many other places you can store persistent data. These are a bit more restricted now. This one has like a local origin restriction on it or something like that. So there's Adobe has some sort of search index thing that the PDF interfaces with. There's DRM, of course, and you can attach arbitrary files, have a PDF that renders completely differently depending on whether you're viewing on a screen, on a printer or a printout, or in a slideshow mode. And there's So last year when I was reading through this spec, about 400 pages in, I came across this. And here I'll highlight it a bit. It basically says that if you, there's this particular action type that if you pass the name of a file, or a program basically, it will execute it with the arbitrary command line arguments that you give it. And I was reading this and I'm like they couldn't have done that. I mean, somebody would have noticed that, blindly executing an arbitrary program with arbitrary arguments, might not be a good thing. But it turns out, so like if you actually put like command.exe in there, would it run? And actually, yes, actually it would. Let's see if I pronounce his name right. DJ Stevens publicized this back in spring, and Adobe has sort of fixed it. They put up a big message box now saying, warning, do you really want to run command.exe? Oh, yes or no, before it does this now. But the funny thing is that there were at least 2 PDF readers that did this. So there had to be at least 2 people who read the spec and thought this was a good enough idea to implement it in their PDF reader without realizing what this meant. So let's see. In older versions like 1.5, there was a whole bunch of stuff you could do from the JavaScript that's a bit more restricted now, quite restricted. Add and remove menu items from the program and toolbar icons, send click events to them so you could like add a menu item and click on it. Read and write files on disk, make arbitrary network connections, send email, call JavaScript and other documents. It's interesting, you can actually, the code to do it looks kind of like this. You can either read it off the local system or off a URL and then just call some function that's defined in some JavaScript blob inside of one of those. So there's, in current versions, there's a privileged context in which this stuff works. And it's a little bit, there's not very much information in the spec about it. There's apparently some sort of X509 certificate authority that has apparently some keys somewhere, I don't know, that are trusted to sign PDFs. And if a PDF is signed with one of these keys, then you get to do all that stuff again. Or if it's also running locally, or also you can just go into the preferences and turn off the restrictions on it also, which is how I did a bit of the testing on this. The syntax, like I was saying, it's all 7-bit ASCII. It's pretty, you can actually sit down and write a PDF file with a text editor. It's got Boolean types, number types. Strings are bounded by parentheses. Hex strings are have got greater than, less than signs. And if it's an odd number, they did actually specify in the standard, if it's an odd number of characters in the hex string, then the last one is a 0. So names start with a slash, and arrays are inside of square brackets. Dictionaries are just associative arrays, so foo is equal to 1, 2, 3, and bar is equal to true. And streams are kind of like giant strings. It's basically when you include like a big graphics image or a font or whatever. It's a lot easier to do this instead of escaping parentheses or whatever. There's a null object, although anything that doesn't exist is automatically a null. And then objects, where you can just take any of this stuff and stick it between that, and then you can use it, make references to it with the R operator. And so if you have an object that's a string like hello world here, and then you make a reference to it here, so example is equal to hello world, it's equivalent syntactically to just putting the original data in that spot. So the thing is that it doesn't do it at parse time. So if you define that object to be like 12, that doesn't actually substitute. Similarly, this doesn't work because these don't really exist at parse time. But if you do it this way, then it does. Anyway, so I suspect I haven't actually like reversed the actual parser or anything. I'm just like feeding it PDFs. But anyway, I suspect it does the evaluation when it actually goes to use the object, which is probably a good thing, because if they hadn't, they would have accidentally reinvented Lisp. And I don't know, actually, I haven't actually tested other PDF readers to see if there are any readers that actually do the reference evaluation at parse time. If that's the case, then you could actually, then they are Turing complete. But streams. There's also a lot of ways of encoding a stream. The other advantage of a stream, aside from being a giant string, is you can compress it, and you can compress it one of 16 different ways, all simultaneously in any order you want. And there's also an encryption thing. And there's apparently in older versions, possibly still in current ones, if you RC4 encrypt a stream with a null password, Acrobat's smart enough to figure out that it was a null password, and it'll silently decrypt it without prompting the user or anything. So there's a lot of things like that in Acrobat. Strings, names. You can put in various hex escaping with the pound sign in names. C-style backslashes work. So Metasploit uses a bunch of these tricks when generating PDFs, because GA wrote a blog post about it 2 years ago or something. So everyone does this now. Graphics. So the graphics operators are also completely different language of their own also, and they follow the format of having an opening and closing tags, and where you kind of shift into a particular state, like, oh, this is the text rendering state, and then a bunch of operators, and the operators are basically kind of Forth style, where you've postfix or whatever. Looks kind of like that. Anyway, I haven't spent a lot of time digging into that. JavaScript. So JavaScript, all of the metadata in the document is both readable and writable from JavaScript. Writable. Some of it, actually, some of the metadata is read-only in Reader. And you need like the publisher or whatever to modify some of it. But there's a lot of places to hide data in a PDF. If you're, say, going to obfuscate your PDF, you can stick part of it in an icon or in the legal warnings or the links or whatever. This has to do with like the DRM stuff and so forth. Some of it is kind of metadata that's you figure out when you actually render the thing, like the number of words on a page. Some of these, actually, if you're using these for obfuscation, and you're trying to figure out what the output of this function is, if you're not running this thing in Acrobat, some of these can be a little bit difficult because things like this function return the coordinates of the bounding box for a particular word on the page, on a particular page. And so you'd need to actually graphically render the page just as Acrobat would to find out what the answer to this is. There's a bunch of intrinsic metadata about the file. You can also check file size, file name, and so forth. So if people are manually trying to analyze it and they muck around with it, whatever. I've only ever seen this done in like hacking competitions or contests or whatever. So I took this slide straight from Sebastian Porst's slide deck because he gave a talk similar to this a few months ago. He did a PDF dissector. There was also a funny thing about the JavaScript engine in Acrobat is that there's some slight differences just in the language itself from how it behaves in a web browser. He used this as an example, and what is that if you define a global variable as, say, like a particular type, and then reassign it to a different type later, in web browsers, it's the new type. But in Acrobat, for some reason, it retains the original type and doesn't change. He speculates this is because it uses C++ for the backing storage or whatever on the JavaScript engine. But so, like, if you make this variable a Boolean and then assign it a string, web browser says, oh, it's a string. If you do the same thing with in Adobe Acrobat, it ends up remaining a Boolean instead of turning into a string. So if you're using like CMonkey or one of those engines, you need to be aware of this because CMonkey does it that way. Some malware is starting to use a few of these tricks, not very many. That's weird. Neosploit, it just essentially picks a bunch of metadata off of a bunch of annotation objects. Annotations are like sticky notes you stick on the page. In the early ones, they would just pick up the subject field. Some of the later ones use author. The newer ones are doing something completely different from this, and I haven't updated these slides yet. But the crime pack similarly actually does actually involves like a little bit more computation or something if you're figuring this out, in that it gets picks words off of the fourth page, and so you need to know what words are on what page in order to essentially run through this loop, which is the decryption routine. Whatever comes out of this gets evaled, so it's a lot of those. There's most of the targeted attacks I've looked at so far. They also do the same metadata tricks. Either out of the annotations, or there's actually a metadata for the document itself, which is this info object. There's also, I don't know, some tool, I suspect it's Chinese, that's making a lot of these, and it's not producing well-formed PDFs, I noticed, because it looks like it took a regular file and like tore out one of the objects, but like left everything in place, and then like wrote nulls or spaces over it, and then wrote an exe on top of it, but then when the malware author like updates their code, then it writes a new copy on top, and if it's shorter than the end of the previous exe on there and stuff. I know it's something I haven't I need to look into when I have some more time. But so the other thing, since PDF is a container format, all of the vulnerabilities that appear in like QuickTime or Flash or whatever are also accessible via a PDF vector. And the Flash ActionScript Virtual Machine 2 vulnerability from last summer is a perfect example of this, because the initial attacks, people thought it was a PDF ODay, but it was actually a Flash one, and because the initial attacks were delivered via a PDF included in a email message. Similarly, this is from earlier this year, there's a 4-year-old vulnerability in libtiff, which apparently Acrobat had been using, but it had been keeping up to date. So the vulnerability was still present in Acrobat up until like this summer. And anyway, so basically you would just stick a TIFF in the PDF and hit this particular block of code. Anyway. So when you read through the specification for the PDF file format, what you really pay attention to is what it doesn't say. For example, the strings, the streams. Well, rather, there's usually two common ways of representing string data. You either have a beginning symbol, and then a bunch of stream of symbols, and then an ending symbol. And if you know where the beginning is, you can leave the first one off. Or you have a count of symbols, and then a bunch of symbols, and that's Pascal style versus like C style. So PDF streams use both simultaneously. And if they don't agree, there's nothing in the spec as to which one you should trust, or which one wins. So if you write something like this is how it usually looks. There's a length that says there's 50 bytes in here, which there is, and this is the beginning of it, and that's the end of it. But if you want, in the case of Acrobat, if you change the length, then it still reads this just fine. So it's basically looking at the stream and end streams for that, particularly if it's missing. And you actually don't need the end stream there either, because this is also a terminating symbol for the object. And so you can leave that out too, and this is also perfectly fine and works just well. Anyway, there's also no way of escaping the end stream if it appears inside of a stream. There's, like, for example, where does this stream actually end, and what is inside of it? The answer is not that simple, because if you say there's 40 bytes in this stream, 40 bytes is the line feed right there, then essentially this is what's inside the stream. Okay. If you, and you can, it doesn't actually matter what it is, you can even have end stream in there. If you have the length being something wrong, so it's like pointing down off past the end of the object, then it stops the first end stream token, and these don't count, they're ignored. If you leave that out entirely, then this is a null object, basically. Although strangely enough, if you explicitly put null there, then it stops the first end stream again. The other interesting thing is that the length may or may not include the final line feed. There's supposed to be a line feed before the end stream, but if you point at the line feed instead of at the beginning of the end stream, that's okay. These are both equivalent. If it's, because it's basically looking for, it seems to be looking for either being 1 or 2 bytes away from an end stream. Because if you end up more than that, then it goes back to falling back to using that as the end of the stream. But although the other thing is though, if you set up the cross-reference table correctly, so that PDF can still figure out where the objects are normally, you can also just say that the length is all the rest of the file. And it'll happily slurp the entire rest of the raw data in the file up into the object, or however much you want. And while you can still, and simultaneously, you can still use the objects inside of it, because I don't even know what to call it. So this morning I was actually I believe it's actually possible to write a PDF quine doing this trick. And I was working on this one this morning. I'll show you how I think it'll go, but I didn't have time to finish it before my talk right now. Other things, there's some stuff's kind of versioned a bit. You used to be able to use the old style PostScript type of headers in the beginning. They drop support for that a while ago, but if you're trying to target like an old version of PDF, you can use one of these. What else? Yeah, likewise. So anything that's not defined is equivalent to the null object, and if anything, likewise, none of these are actually defined. So this is perfectly okay. Also, any tokens that aren't recognized are ignored too. So you can just put whatever you want, in between the objects. It's fine. In the spec, so at the end of the file, or at least the end of each revision, if you add a new set of objects, you write another one of these. But there's a cross-reference table that basically just gives you the offset into the file where each object begins. It looks kind of like this. It's pretty straightforward. It basically says there's no object 0, so that's what the F means. Object 1 starts at 10 bytes in, object 2 starts 98 bytes in, object 3 starts 147 bytes in, and so on and so forth. Spec says it's required. Like I said, doesn't go anywhere. Acrobat doesn't actually care about these. If these are completely bogus values, this is still perfectly fine. And you can also just leave it out entirely, and it's still okay. Because I guess Acrobat's parser falls back to actually looking for the object tokens directly. The PDF header is supposed to be at the beginning of the file, although it actually only needs to be within the first 1 kilobyte of the file, and it doesn't actually need a number after it. So as long as that's somewhere in the first kilobyte, this is perfectly okay. And it'll be recognized as a PDF by Acrobat, and also OS 10 previews will as well. So, so you can stuff whatever you want in the first kilobyte, like a GIF or a JPEG or a PNG or a zip file or Windows exe. And so I just did a quick example using zip files. There's generally, whoops, there. So usually there's a, if we assume for a moment that the end of file token actually has to be at the end of the file in a PDF, this is not actually true, but if it is, you can basically split the PDF in half so that the end really appears at the end, because the end of a zip file is a 65K of arbitrary data. It's the zip file comment. So you can just stick this in the comment, and then put this, just store this as one of the objects near the beginning, anywhere in the first kilobyte. And it should still be a PDF. So generally, a zip file looks like this. It's got a little zip-tree header, like the file name and stuff like that. Then the compressed data, although you can use no compression. And then a central directory structure that basically says, oh, object entries 1 starts at, has this file name and it starts at offset 0 or whatever, and then comments at the end. And when you actually do that, you end up getting this. That's a zip header, there's the PDF header, and there's the PDF file, and then there's the central directory structure, and there's the disk, end of disk thing that basically points to the central directory structure, and then there's the rest of the PDF there, all the way down to the end. So the end of file appears at the very end again. If you just do it like this, the cross reference will be wrong, but Acrobat doesn't care. You can change it if you want, but so it actually turns out you don't actually have to do this, because the end of file doesn't actually have to exist anywhere. You can put megs and megs after it. You can leave it out entirely and stuff. You can even put it at the beginning of the file. And so doing something like this is okay. So you can just store the PDF, and it still ends up being, you just store it without compression, and the zip file ends up being a PDF file simultaneously. And if you want to make analysis kind of annoying, you can start putting pieces of the PDF into the metadata in the zip file, so that when you unzip the zip file, they disappear, because they're not actually inside the file, the zip file, that is. So you can, in this case, I just stuck the PDF header into the file name, and then took it out of the actual file. So when you zip this up, the file name goes right before the rest of the compressed data. So when Acrobat sees this, it's like, oh, that's a PDF. And but from Zip's point of view, this is the actual beginning of the data. So when you unzip it, it starts there, and that doesn't end up in the beginning of the file. So you can leave a bunch of stuff out. The end object and end stream tokens, if you got one or the other, it's okay. But if you leave them both out, then the parser does get really confused, and I haven't quite figured out precisely what the behavior is for that. So doing something like this is okay. And doing something like that, either that or that, but not both at the same time, because if you do that, then the objects start to merge together. And I haven't quite figured out what the behavior is, but yeah, it does that, something like that. So you can also leave out most of the objects, or actually just all objects, references in general, just have them explicitly defined in place. You do need the, you can leave the catalog type off, because it's obviously the catalog. because of how it's called. A bunch of the types you can actually leave out because they're kind of figured out from context and stuff. And all the sizes and links of all the streams you can also leave out because Acrobat will figure it out from the actual data it has in hand. So if you take all the stuff you don't need out of a PDF, this is all you actually need to, say, run JavaScript. Basically, there's the beginning of the file, there's the end of the file, and it says there's a root object with pages, no pages rather. You have to have the pages, but you can have 0 pages. And then you just have an open action that runs the JavaScript. Ta-da! That's about 75 bytes or something. So you can also, there's two optimizations people pointed out to me, is that if you replace that with a null byte, then you can actually shave off 2 bytes. And then if you also use the on-close action, it's a few bytes shorter than saying on-open. Although the thing is that because it's 0 pages, there's a funny thing. When you open up when Acrobat opens a document with no pages in it, it kind of sits around doing nothing for a while, and then when an event actually gets sent to it, like you scroll on the page or something like that, it goes, oh, hey, wait a second, there's something wrong with this PDF document, and then it pops up an error. If you do the JavaScript on open, it runs the JavaScript before that happens. If you do it on close, that happens before. And if the person just closes the Acrobat instead of clicking OK, then the on close never gets run, but whatever. So it's only like 20 bytes difference. Anyway, but you can stick the PDF in a lot of places. This is just in a zip file, for example, but you could also stick it like in a GIF comment. So this is a well-formed GIF. It's also a well-formed PDF as far as Acrobat's concerned. And likewise, here's an HTML file. It's also a PDF document, same one. And I actually had a ping example too. If you go to the, I didn't have time to stick it in here, another slide, but if you go to the CCC talks wiki or something like that, I need to make a picture for the talk. And so I did a picture of this thing, but I did it as I put all the PDF code in a text field in the ping file. So the ping actually, if it hasn't been transformed or anything, up on the wiki is also one of these PDF files that'll run some JavaScript. So let's see what else. Oh yeah, you can define the object more than once. It's not really, it doesn't quite explicitly say what the behavior is in the spec. Although, since you can do like infinite revisions on all of the objects, but just by appending new ones to the end, that's pretty much the behavior that it follows. Although if you don't quite do it right, so I mean, if you don't quite do it the way the spec does, it still works anyway. So if you define object 7, twice, this one is the one that actually runs. And even if you point your cross-reference table and say, that's really object 7, it still runs that one. And if you even do an update, say, oh, this PDF was updated, and these are the new objects, and this is a new cross-reference table, and you point at that one there, it still runs, I mean, if you point that one there, then it still runs that one. So you can also, reference certain objects more than once, so you can make like a 100-page document with only 1 page in it. This is useful if you're writing PDFs by hand and are really lazy and you don't want to write 100-page objects. You just use the same page over and over again. The other thing in the spec, it very explicitly says that a PDF, like the page tree, is a directed acyclic graph. Although it doesn't say what happens if there's a cycle in it or whatever. I've been when I read that, I was kind of curious as to how many PDF parsers would go into an infinite loop if you fed them some objects like this, because each of these is each other one's parent or child object. And Acrobat will throw an error when it encounters this, but I haven't tested other PDF parsers to see if any of them will go into an infinite loop when you hand them that. Demo time. So I was going to do some slides explaining what's actually going on here, but I'll just have to show you. Just a second. Whoops. That's not what I wanted to do. So I did a three-way combination of hold on a second. There we go. Hold on a second. I took the Windows calculator program and I stuck a PDF inside of it, and also I made it a well-formed zip file. So it's all 3 file types simultaneously. And I mean, you can't really say it's this type or it's that type because it's all of them. Here, I can show you what the insides look like. Basically, it's the Windows calculator program, but there's a bit of space after the segment table, so I started in there because it's within the first K. The text segment has to start on a 4K page boundary or something like that, so there's usually a bunch of empty space before the text segment. So I stuck that in there, and then I basically said, oh, the text segment, that's a stream object, so it's perfectly okay from PDF. It's not just a bunch of white noise in the middle. And then, oops, and then stream. And then the end of the text segment's there. So I said, oh, yeah, that's the end of the stream. And then I put in some more PDF stuff because there's a bit of space before the next page, and this is the data segment. And so I said, oh, yeah, the data segment, that's another stream too. And then down at the end, and then say, oh, okay, that's it for that stream. That's the end of the resource segment. And then there's the rest of the PDF. And then this is a zip file, and that's the beginning of the zip file there. Because Windows looks at the beginning of the file to figure out if a file's an exe. Zip looks at the end of the file to figure out if a file's a zip. And then PDF looks somewhere in the middle, kind of near the beginning. And and the thing is that in the zip file is basically the central directory structure is basically just a thing that says file name, size, CRC, whatever, and offset to the entry in the file. And normally it starts at 0, but if you take your zip file and you stick like a couple kilobytes of data in front of it, you can pretty much just add the delta between that and 0 to the two offsets in the zip headers, and then unzip sees it perfectly fine. You can put all kinds of data in the middle of a zip that way. Anyway, but there's the cross-reference table. It's in the comment on it. So the end of file tag really does appear at the end of the file this time. All that's unnecessary. But so if you unzip this, see no errors detected in the compressed data. And I was actually I believe it's possible since PDF uses the deflate algorithm, which is the same thing that zip uses, and zip entries have a comment at the end of the entry just before the compressed data. And you can put whatever you want after the compressed data in a zip file. I'm pretty certain it should be possible to write a PDF file in which all of the compressed objects in the PDF are also compressed objects in a zip file. So when you unzip the zip file, you extract all of the objects from the PDF, because all you need to do is put like begin stream and the zip file comment for each of the zip files, and then an end stream at the end, which zip will ignore, and then bump up the appropriate offset for the next zip header. And that should work. I was going to write one of those last night, but I didn't quite have time. So if you so anyway, this is the file. It's a zip file, and once I figure out where my mouse pointer is, so I dropped it onto this Windows box, and you see it's, oops, there it is. It's the Windows calculator program, because that's what I started off with. And so you run it, and it still works perfectly fine as an exe. And then if you open it up in Acrobat, it opens it as a PDF and runs a JavaScript inside. So, and I also believe it should be possible to also put a RAR file in the middle of that too, because RAR doesn't care where it starts either. But I know one of the things on my to-do list. Oh, and also as far as quines go, I believe a PDF quine would look something like this, but I haven't. This doesn't work. I was working on it just before I got up on stage. And I'm pretty sure if I muck with this for like a few more minutes, I can probably get it to work. But basically, it is an object, and it says, oh, the rest, everything down to there is an object, and this takes the contents of that object, prints them back out with PDF before and after and mainstream. And I think those are optional. I can probably chop those off. But anyway, so back to my slides. And all right, is there any questions so far? You.
Yeah, use the microphone, if you're good. if you're going to ask questions, please use the microphones that are available.
It's very interesting to see what Acrobat does, but have you tested other readers as KPDF or
No.
ePDF? Okay.
The question is, have I tested all readers? And no, actually, I've only looked at Acrobat for the most part, and a little bit at OS 10 Preview, but just because I'm testing this on a Mac. And you had a question, or no, you don't. Okay. So I did a couple of tests a few months ago, and before I start, can anybody guess what conclusion I'm about to draw from all this? So I took a took a 2-year-old exploit out of Metasploit, cleaned it up so it wasn't even obfuscated, and everyone should detect this. It's like ancient and easy to see and stuff like that. I uploaded a bunch of, I uploaded it to VirusTurtle, and VirusTurtle, blah, 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 it's, a lot of people, AV companies complain because it's not doing like the memory runtime analysis, it's only doing static analysis and blah, 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 and it doesn't really matter in this case because it's PDF. So, anyway, this is the code I stuck into a regular PDF. Back in May, I uploaded it, and only 9 out of 41 antivirus programs detected anything, and most of them were generic signatures. You can see it's the heuristic stuff, gen. This morning, I uploaded the file again, and now it does like 18 out of 43, and I ran out of space here, but there's a few more after this. And so it's gotten a bit better. Like I said, I took out the percent sign hex stuff because most of the time that's probably what they're looking for. And when you do that, actually, this example doesn't work, obviously. If you do that, it drops down to 2, or at least it did back in May. There's now about 14 out of 43 that will detect it as of this morning. And I didn't cut and paste the whole thing on here too. Nobody's going to read that. It's tedious. Just go look it up if you care. So I stripped down everything except down to just the actual statement that triggers the vulnerability itself. Nobody detected it back in May, but today, as of this morning, AVG apparently will detect it as exploit C or something. I don't know. It might just be because they saw my talk a few months ago. I've been passing these samples around to various researchers, so I'm not surprised. Was anybody surprised? Yeah, that's what I thought. And generally most of the actual in the wild live exploits I see are generally detected by almost nothing these days. Although my company will detect all this stuff. And ask me later if you want info on that. Because we use Adobe Acrobat for parsing PDF files. So, what was this? Oh, so I did the zip file trick, and just storing it, you end up getting about the same results as before. If you do this thing, I mean, this is what it was back in May. If you do it now, it's the other 18, like the other one too. If you do the file name trick, so the PDF header disappears when you unzip the zip file because the antivirus program says, oh, this is a zip file, I'll unzip it and scan the contents. Oh, but this isn't, what is this file type? It doesn't have a PDF header at the beginning, so it's not a PDF. And so that drops it down to about 5, or at least back in May. What was it? There's like 10 now as of this morning. And I didn't bother writing that on the list here either. If you do if you do this trick, and if you do the trick where the PDF disappears, and also you compress the JavaScript, then it drops down to 2, but or at least back in May. But something to keep in mind though is if you go and look up this Google for this signature, you see a lot of people complaining that it detects like Google Mail as being malicious. It's kind of it's their heuristic thing that kind of false positives on everything. I don't know much about the Surface one. Anyway, today it's like 6. So, oops. So I only spent like an hour or two on this, and if anyone else wants to actually do this experiment like more formally, go ahead. I just need another section of the slides because everyone asks me about this. I actually don't know what else to add about about antivirus programs. Anyway, so I have a kind of a to-do list of things to work on someday, because I believe it's possible to do heap spray using the graphics operators to basically paint the heap, paint your shellcode into memory however you want it to appear. Although there's actually a much easier way if you just generate your heap as you want it and then compress it. With zlib, because it's very redundant, so it compresses very small, and then when Acrobat goes and uncompresses it into heap memory, ta-da. But this is a much more sophisticated kind of show-off kind of hack. There's PDF client. I gotta get that done. There's an amazing number of graphics operators that you have available, like tensor cross-product triangle meshes and so on. I believe it's possible you could obfuscate data by taking the data you want to hide, like XORing it or doing some kind of alpha channel blending or whatever with white noise, and then basically taking the output of that, the white noise and the output of that, sticking them in the PDF, and then having the PDF recombine them back together again graphically, and you get the original data back out. I believe it should be possible to do that as well, but I haven't actually tested this. Let's see, what else? Actually, there was this guy down in Argentina who did actually do a heap spray using inline images, but I haven't had time to really look at it closely. Anyway, since there's a bunch of ways of doing alternative data streams and stuff like that in PDFs, so you can have a PDF file that has different text on the page for each language, depending on the locale of the computer you open it on. There's also some, even without using JavaScript, it's possible to do that, and I think even the other stuff you can do with that JavaScript, but basically all of these are quite, all available from the JavaScript at least, so you could, make a PDF file never look the same on any two systems. I haven't tested that yet either, but somebody said we should also write database scanner, and since a lot of printers these days have PDF engines in them as well, depending on how full-featured the PDF engine in your printer is, it may be possible to scan your databases from your printer when you go to print a document. I'd be really surprised if that would actually happen, but maybe not. TrueType fonts also have a kind of a little programming language in them as well, but I haven't quite figured out anything useful to do with them as far as attack kind of things go. A lot of stuff. There's there's a stripped down PostScript that still exists in there as well. It's mostly, as far as I can tell, only used for dot screen functions and only when you go to print the thing on a printer, and so I haven't really spent a lot of time experimenting with it because I wanted to write a Mandelbrot generator in the PostScript interpreter in the PDF, but whatever. So in conclusion, okay, any more questions?
Can you put your hands up if you want to ask questions, please, and let the audio angels know.
So, have you thought what implications would it make if you not only tried printers, but mobile phones, some of them can read PDF documents?
Yep. There was actually, like in August, actually, there was at least 1 or 2 PDF engine O-days in the PDF engine on the iPhone. The jailbreakme.com thing was basically using an O-day in the PDF reader to essentially jailbreak your phone. So,
next question.
There's a PDF/A format which is used for long-time archiving, data of 80 years or something like this.
Right.
This should be a subset which should be stable.
It should be.
Did you look into it?
No, actually, I should have added it as my to-do list. Yeah, it's basically PDF/A is the archival PDF. That's it's basically the 1.7 spec stripped down, so there's not like a JavaScript interpreter in it, and it's supposed to be, deterministically rendered, so it does appear the same way to everyone. But I haven't actually really spent any time looking at it.
Because as a side remark, this is the intended format. If you look into this infamous Ausweis app in Germany, this is a format where the documents should be signed in, which are presented to the user before he signs it with his German new Personalausweis. So this should be worth a try.
Yeah.
Okay, we'll take a question from IRC. Next.
Okay, first of all, the chat is ask itself if it's good to open your PDF slides, or if there's anything in there. And there was a question about the page count in the PDF files. What happens if you make them really large? Could you trigger
Actually, I
some
don't.
bugs?
As far as the really large count, I don't actually know. Although I do know that I did notice when I was experimenting with building a page tree that OS X Preview and Adobe Acrobat look at different things to figure out what order the page is in. And so I ended up writing a PDF file where the page is rendered in one order, like 1, 2, 3, 4, 5 in Acrobat, and rendered in reverse order 5, 4, 3, 2, 1 in OS X Preview. It's the same file. I didn't put the stuff up here, but it's. I think it's like one looks at the explicit name of the page, and the other one looks at the order in which they appear in the array. But see, first part of the question was, what did you just ask? Wait.
Well, the page count question you just answered, and the other question was if it's safe to open your slides.
Safe to open. So all of my slides I've been putting up lately, I've actually been sticking a little comment in it, saying that, if you read this comment, that, I don't know, whatever it was. I didn't have to actually put anything clever in there, but I did put a little comment in just for the people who could look.
Another question, have you experimented with signed documents and subverting the signature or something? Signed documents in Acrobat.
So the question is if I tried subverting signed documents yet, and I haven't tried that yet. I know that there is some, if a document's signed, I think there was some extra restrictions that kick in on the JavaScript or some of the objects, but I'm not 100% certain about that. It's another thing to look into. There's a lot of stuff in the PDF format. Just the ISO docs for the PDF syntax itself, the JavaScript documentation, and the XML forms comes at like 2,500 pages of text.
Jesus.
And it's not even entirely documented. I've found stuff that's not in any of those.
Okay, other questions? Put your hands up. That gentleman there.
What about same origin policy when it comes to XML communication and the SOAP part?
Currently, I believe it does do same origin.
How does that work when it comes to PDFs loaded on, when it's not in the browser?
I'm not 100% certain. I've only spent a little bit of time experimenting with the forms, and I do actually have a PDF file that will go and connect to some website, but it originally came from that website. But I don't know if Acrobat's keeping track of that, or if I went in and changed the URL, if it'd go somewhere else. So I'm a little bit fuzzy on that part. It's in like chapter 14 of subsection whatever in the ISO spec.
The hybrid file you had, the one with the calculator, file you had, the one with the calculator and the zip file and the PDF file, have you tried to edit it with the Adobe Acrobat? I don't know how it's called, the Adobe tool to edit PDFs. Does this editing of the PDF file break the exe file or the zip file?
So the question is, if I edited the hybridized exe PDF file, would it break the exe part? And I haven't actually tried it with Adobe's tools, but I know when I've written PDF files before and then modified them in the OS X preview program and then saved them back out, it completely rewrote the file because like even the graphics operators, because I had like nice, neat like graphics code, and then it turned into this big mess of basically. I'm suspecting that Quartz is basically just serializing the graphics objects it has in memory into the PDF. But
Okay, we have time for maybe another 2 questions. So if-
Hello, yes. I have a question what you imagine the solution to this could be. So personally I could think of some PDF parser which only reads documents with a tightened spec, or do you know what they imagine the solution to be to this, or what do you think of?
So Adobe's solution as far as the huge vulnerability surface in Acrobat is to sandbox Acrobat, the program itself. They started with version 10. It's still got a bunch of, it's not a complete sandboxing yet. And as far as other things, some people have suggested writing a PDF scrubber, and I think that might work. It's a slightly less work than actually writing a full-blown PDF rendering engine because you don't have to really deal with the graphics. You just have to check for syntactic conformity. For the thing is that the spec doesn't actually say what is a conforming PDF. So when you write the scrubber, you get to decide. Yeah, aside from a scrubber, there's my company's product, but I'm trying not to make this a commercial pitch. Ask me later if you want to know. Or you can ask me now if you want. But I won't do it unless someone asks.
Okay, we have time for one more question, if there's anything else. Anyone? Going once, going twice, going 3 times. Well, thank you very much, Julia.
Okay.